let's look at the true and false questions for chapter 4 along with some exercises. For the first one, an event represents all of the possible outcomes of an experiment. That would be false. The event, the first customer in the store today will be female, is an example of a simple event. That is true. The sum of all probabilities for the simple events in the sample space must be equal to 1. Absolutely. That's one of the main rules in probabilities. The complement to event A is defined as all of the outcomes in the sample space that are not part of event A. This is true. The probability that event A or event B will occur refers to the union of event A and event B. That is also true. The addition rule for probabilities is used to calculate the probability of the union of events. That is also true. If the occurrence of one event affects the occurrence of another event, the events are considered mutually exclusive. That is false. Let's look at the multiple choice questions. 2 6-sided die are rolled. Calculating the probability of the sum of the 2 die being a 10 is an example of using a classical probability. Each outcome has the same probability of occurrence. 2 6-sided die are rolled. The probability of the sum of the 2 die being a 10 is 0.083 will be the correct answer. Which of the following is not a valid number for a probability? Which of the following is not? That would be 1.5. You can never have a probability that's above 1 or a negative probability. A survey of adults who typically work full-time from home recorded their current education levels. The results are shown in the table below. So you have the education level, you have the frequency, and I want to find the probability that a randomly selected adult who works from home has less than high school diploma. Less than high school diploma, we are here. We calculate the total. The total is 64. So the probability will be 3 out of 64, which is 0.0469. If we were to round up to the second decimal, the correct answer would be B. Dempsey's Garage repairs domestic and import cars. The following table shows the number of cars that have been serviced by age and type during the last month. When you are given a table, the first thing you want to do before you start calculating probabilities is just find the totals. So you add the columns, the rows, and what we call the grand total. That means the total number of entries. Now, the probability that a randomly selected car from this group was an import, given that the car was from 10 to under 15 years old, is. So, what do? We want to find the probability that a randomly selected car was an import, right? So we are in this column. Given the fact, however, that it's 10 to 15 years old, that means that we already know this category. That means that our total becomes 32 from 80. Where do these two intersect? Right here. So your probability will be what? 20 out of 32, which is 0.625. If you were to use your formula, you would say for conditional probability, we want to find the probability that we have an import car given that is 10 to 15 years old. 10 to under 15 years old. Basically, this is how you would write it. So this probability would be probability of import and 10 and less 15 over the probability of 10 to less than 15 years, basically. So, point of intersection over 32. All right, so the correct answer will be C. Same table. However, here I want to find, given that a randomly selected car from this sample was an import, the probability that the car was from 5 to under 10 years. From 5 to under 10 years, we're right here. Given the fact that it's an import, the total for imports is 38. So your probability will be 12 over 38. Because we already know that is an import, therefore we use the total of import instead of the grand total. So the probability would be 0.3158. If we were to round up, would be B. If A and B are independent events with probability of A to be 0.4, probability of B 0.25, then probability of A and B would be what? Probability of A times probability of B, which means 0.4 times 0.25. Therefore, the correct answer will be C. Let's look at the problems. The following table shows the range of math SAT scores for the incoming freshman class of business students at Smith University. So this is the data that we have. Determine the probability that a randomly selected student scored from 400 to under 450. So the probability from 400 to under 450. First of all, we add all, we find the total number of the students. The total number of students is 326. So this probability, we have, this is our category that I'm interested in. So we will take 98 over 326.301. Determine the probability that a randomly selected student scored from 450 to under 500. So now I'm interested 450 to under 500. So this would be 0.3252, and determine the probability that a randomly selected student scored 400 or higher. 400 or higher. So basically, what we need to do is find the probability of 350 to under 400, which is 40 over 326.123. and then we take 1, which is the total for all the probabilities, the sum of all possible probabilities for the event, minus this probability, 0.123, and that will be 0.877. Now, for the second problem, the following contingency table shows the number of customers who bought various brands of inkjet printers and their gender. So you have your table, and you want to find the probability that a customer bought a Canon printer or Brother printer is. So you will have the probability of buying a Canon printer, which is 24, the total here, over 150, the grand total is 150, plus Brother, we have 6 over 150. They do not have a common point, therefore we simply add their corresponding probabilities. So 30 over 150.2. The probability that a customer bought an HP printer or is a female. HP or female. So this will be equal to the probability of selecting a customer that bought an HP printer. That probability will be 51 over 150. You have HP, the total here is 51, plus the probability of selecting a female. Female total is 66. 66 over 150 minus HP woman, where is the point of intersection? 21. Minus the point of intersection. I want one or the other. I do not want both. Therefore, I have to take out that probability. So this is going to be 96 over 150.64. Now, the probability that a customer bought an Epson printer and is a male. You simply go for the point of intersection between the two. Epson, male. Where do they meet? Right here. Epson, male. All right. So 9 over the grand total, 0.06 for the probability. Let's look at problem number 3. A random sample of homeowners from Maine and Delaware was asked to identify the primary source of their homes. The following contingency table shows the results. What is the probability that a home uses oil as its primary source of heat and is located in Maine? So now we're looking for point of intersection because we have N. So oil, Maine, where do they meet? Right here. So your probability will be 20 over the grand total. Your grand total is 500. So this probability will be 0.04. The probability that a home uses natural gas or is located in Delaware, we would take the probability of a home using natural gas, which would be 265 over 500. The total would be here 265 plus the probability of someone located in Delaware, which will be 185, that's your total, minus the probability of both gas and Delaware. The point of intersection is here. You need to take this out. You need to take this out. So minus 105 over 500, and the probability will be 345 over 500, 0.69. 0.69 for the probability. The probability that a home uses electricity as its primary source of heat, given that the home is located in Maine, is, so I'm looking for the probability of using electricity given that we are located in Maine. So this will be equal to the probability of electricity and Maine, point of intersection, over probability of Maine. So electricity and Maine, what is the point of intersection? We have 0.23. We have 115 over 500, 0.23, over probability of locating in Maine, which is 0.63. 315 over 500, 0.63, sorry. So this probability will be equal to 0.365. Given that the primary source of heat is natural gas, what is determining the probability that a home is located in Delaware? So we want probability that a home is located in Delaware given that it uses natural gas. So this will be equal to the probability of being located in Delaware and using natural gas over the probability of using natural gas. So the probability of being located in Delaware and using gas, you go back to your Delaware gas, 105 over 500, which is 0.21. The probability of using gas, 265 over 500, 0.53. So this probability will be 0.396. Now, the following contingency table shows the number of adults with credit scores 725 or above and below 725, as well as the marital status. Identify the marginal probabilities for this table. All right. So, the probability of A is, let me just do that. We're going to do 39 plus 15. We have 54. We're going to do 33 plus 63, 96. 150 is our total. We will do 39 plus 33, 72, and we will do 15 plus 63. This is 78. All right. So, if we were to calculate the probability of A and C, that would be 39 over 150, which would be 0.26. So I will put them in a parenthesis here, 0.26. The probability of B and C, this would be 0.1, 15 over 150. The probability of A and D, that would be 0.22, 33 over 150. Probability of B and D, that would be 63 over 150, 0.42. The totals, the probability of having below 725, so that means the probability of A would be 0.48. Let me write it here, 0.48, 72 over 150. The probability of B would be 0.52, 78 over 150. Let me write it here, 0.52. The probability of being single, 54 over 150, 0.36. And the probability of being married, 96 over 150, 0.64. So this is 0.36, and this is 0.64. For a total of 1. And this concludes